Let's see if I can get the chat back on my phone. Okay. So frequency tables are one thing I asked you to do. An example again of a frequency table was when I did that age distribution earlier in the notes. And any histogram is based on a frequency table. So again, example of a frequency table back here. This is a frequency table. So we have some category from our data, and then we look at how many are in each group. And that could be a percent, or it could just be a number of people, like over here, or number of things. StatKey and Google will make you histograms and then hide the frequency table from you. And at the moment, I don't really care about the frequency table. I just want to see a graph. So reminder, we've done that before. We just highlight the data. We go back up to the top here, say, show me a chart. Often with raw data like this, the computer will say, hey, here's a histogram. Here they're giving me a scatter plot, probably because we were working on those recently. I want a histogram. It picks its own groupings, so 0 to 93,000. And again, these numbers are in thousands here. 93 to 186. So those are kind of weird numbers. So usually I take Google's recommendation and say, okay, that's nice, but let's make it a little prettier, choose nicer numbers, customize histogram. So instead of automatic, I might try 100, rounding that 93 width up. Okay, so notice it looks similar, but the numbers at the bottom are nicer, cleaner. And I have 1, 2, 3, 4, 5, 6, 7 groups. That's okay. And remember, there is no best histogram, and you got to make a couple and decide which one you like. Don't like that one. What if I went like 75? I think I'm going to go with the 100. Okay, so there's my histogram. So how would we describe this distribution to somebody? Do we see a skew? Do we see symmetry? Nobody wants to share. Okay. I see a skew. I see a skew to the right. I would imagine more of a tail on this side. So from the bulk of data, which are these two columns, the right side's further away. So I would say, I think that's the tail there. Sometimes I'm not really sure. And so then I'll mess around with different size histograms, like maybe jump by 80. Still looks like a right tail to me. So I'm going to go with a right tail on this one, but I like the 100 the best. Next thing I want to take a look at here. I'm going to do some calculations. Summary statistics, in particular, I want the mean and I want the median. So what I'm getting at here is how does the shape of the graph affect how the mean and the median are related to each other? So the mean here is average of all of the data, and it's safe to click on the column in this case, not always though. Median is just the median. Data column. All right, so let's grab this into my worksheet to scribble on. Oops, that button. All right, so let's see. The mean is about 260,000. So let's mark that in red. So here's 200, 300, 250, 260 is probably about right there. The mean we usually call X with a bar over it. The median's about 240 roughly. Median is usually given the letter M. And so that one is going to be more like over here, M. So notice in this case right here, the median is less than the mean. Alternatively, we could say the mean is greater than the median. let's look at another example. No, I don't think the Hermiston one's going to be much different, but let's take a quick look. I think I need to look elsewhere for data. Yeah, it's got a definite skew right, but we might as well look at that one too. So Google picked some weird numbers there. Let's clean it up. How about 100 again? Sure. Wow, look at this, 120,000, so $1,200,000 home in here. So that's what we call an outlier, right? And then I want to move this up to the top because I want to calculate mean and median. So again, I want to look at how does the shape of the graph affect how the mean and median are related. And you should have access to these spreadsheets too if you want to try this on your own. All right, so there's my numbers. Let's get a screenshot again. And then just like before, I'm going to mark those numbers on the graph. So same as before, let's let the mean be red. That's what we call X with a bar over it. And that's almost 300,000. So 250, 350, 300 is going to be about right here. That's my X bar. And the median, we usually call that one M. That's 270, which is, let's see, just a little shy of that, right? So maybe about here. So M for the median. And just like before, I have the median is less than the mean. Or reverse, the mean is greater than the median. So here's what we need to consider is how do we calculate a median and how do we calculate a mean? Well, remember the median is the middle number when they're in order. And the mean is the sum of all data. Oops, Zoom is in the way. Divided by the count, right? How many numbers are there? So when I calculate the mean, I need to know exactly what that number is and that number and that number, every single number that I have. I need to know all of them, especially the largest one and the smallest one, right? I need every single number. The median just needs the numbers in order. So as far as the median is concerned, it doesn't care if the biggest number is here or here or here or here. It's still going to be in the exact same place. So the median is not affected by the extreme values in the data set. Extreme, think about extremities, endpoints, or things near the end. But the mean totally is. So this large number here is pulling the mean away from the median. Since it has a right tail, the mean is pulled to the right. So an interesting thing that we'll notice most of the time, if the distribution is skewed right, that those right big numbers are going to pull the mean away because it's used in the calculation. Then the mean will be bigger than the median. Reverse happens if there is a left skew. So if we had a skew on the other side, then we would find the median would be pulled to the left toward the tail because we have to add up those small numbers. And that thing right there is supposed to be a less than. Let's make it a little neater. If the distribution was symmetric, then we should find the mean and the median are pretty darn close to each other. There's no pulling on either side. So they'll just be almost equal if it's a symmetric distribution. There's no pull from those extreme values to either side. So big ideas in this part of 7.3. The idea of a distribution of data, and that's just the shape of a histogram. And there's many ways to categorize the shape of a histogram. The ones we're going to take a look at are just symmetric, bell-shaped, skewed left, skewed right, and we could have some combination of those. We could have a bell with a left skew, a bell with a right skew. We could have symmetric but not bell-shaped, symmetric but skewed left. Lots of different options. Okay. What time is it? Okay, one more topic and then we're good for today.